Hello, today I want to look at some linear equations and how to solve them. Specifically, I'm going to look at a linear equation with one variable. Now, the standard form of a linear equation, one variable, is ax plus b equals c. We have our one variable here, and what makes it linear? Linear means that the variable x is raised to the first power. If it was raised to the second power, then it would be nonlinear. So we're looking at linear equations with one variable. Let me give you an example. 3x minus 5 equals 7. One variable linear equation. Now to solve this, we need to isolate the x. We need to get x by itself. The first step would be to bring the term that does not include the x to the right-hand side in this case, and we do so by adding. We have minus 5, so we add a 5 to both sides. Of course, with any equation, if you want to solve equation, what you do to one side, you have to do to the other side. We bring down the 3x, the negative 5, and the plus 5 cancel each other out, and 7 plus 5 is 12. We're down to 3x equals 12. What is the next step? How do we get x by itself? Well, we need to get rid of this 3. This says 3 times x. To undo it, we have to divide here. We're dividing by 3 both sides, and our answer is 3 divided by 3 is 1. So 1x equivalent to x. 12 divided by 3 is 4. X equals 4 is our first answer. Now the beauty about math is you can always check your answer. Let's check and see if we indeed have the correct answer. 3 times, we're plugging it into the original equation. 3 times x is 4, minus 5. Is this indeed equal to 7? Well, 3 times 4 is 12. 12 minus 5. Guess what? 7 equals 7. Check mark. Yes, we got the correct answer. Good work on my part. Let's take a look at this problem. This is also an equation, a linear equation with one variable, but this looks very long. Here we have to do more than just 1 or 2 steps. In this equation, one of the first steps in solving equations is to clear the parentheses, which means in this case we must distribute this 3 over the 2y and over the negative 1. 3 times 2y, 6y, 3 times negative 1 is negative 3, and that equals, on the other side, we do the exact same. We are distributing the negative 8 over 6 and y. That leaves us with negative 48 minus 8y. Now, again, we need to isolate our variable. I call this moving and shaking. We have to move our variables to one side and our numbers to the other side. I'm a creature of habit, and I usually move the letters to the left-hand side, the variables, and the numbers to the right-hand side. So I'm starting here. I need to move this negative 8y to the left-hand side by doing the opposite, adding 8y, plus 8y to both sides. This is an equation. What I do to one side, I have to do to the other side. Now, you could have also said, oh, I want to start with that negative 3 and bring it to the right-hand side. That is perfectly fine as long as you are consistent with your steps. So we're adding 6y plus 8y is 14y. Bring down the minus 3 equals negative 48. The negative 8y is positive 8. Cancel. To isolate the y, now it's time to move the 3 to the right-hand side. 14y equals negative 48 plus 3 is negative 45. To undo the 14y, divide by 14. And 14 divided by 14 is 1y. I'm going to write over here. So y equals, and we have negative 45 over 14. Yes, fraction action. There is nothing you can do to reduce it. So that means we leave our answer as negative 45 over 14. You do not have to change it to mixed numbers. Please no decimals. Leave it in improper fraction form. The answer is y equals negative 45 over 14. Let's take a look at some literal equations, aka formulas. Literal equations have more than one variable, and sometimes we need to rearrange these formulas for certain letters. So that's what we're going to look at now. Let's do, for example, we have the area of a rectangle, which is length times width. So that is the area, the formula for the area of a rectangle. Sometimes, in certain cases, we need to solve this formula for the letter L. Solve for L. So that means you need to get L by itself. You have to check and see what is associated or what is the whole term that involves the L. We have L times W. To move the W to the other side to isolate the L, we have multiplication here, we have to divide. We divide both sides by W, and off we go. L equals A over W would be our formula in terms of L. Let's take a look at another one. You will see those when you are looking at graphing y equals mx plus b. So here I have 3x minus 4y equals 8. When you have to find the slope and the y-intercept, you will encounter these type of equations with two variables, and we want to solve for y. So isolate the y. You want to get y by itself. That means the 3x has to go to the other side of the equal sign. We have positive 3x. To bring it to the other side, we're subtracting. That leaves me on the left-hand side with negative 4y. And on the right-hand side, please write the x term first. That way you get used to y equals mx plus b in the next chapter, which is negative 3x plus 8. Now what? How do you get y by itself? Well, again, this says negative 4 times y. We need to divide by negative 4, and I would strongly encourage you to write it like that, meaning each term on the right-hand side, write it over negative 4, because now you can easily see what can be reduced. Negative 4 over negative 4 is 1y, or y equals, pay attention to signs, negative 3 divided by negative 4 will change into positive and leave it as a fraction, 3/4 x. 8 divided by negative 4 is a negative 2. So here we go. We just solved our equation with two variables for y, and we got 3/4 x minus 2, which will definitely help you out when you have to find the slope and the y-intercept of a line. Let's take a look at linear inequalities. Now, linear inequalities, what is the difference between a linear equation and linear inequalities? Well, they have the form ax plus b is less than some kind of number c. That is just one example. Of course, we have also the greater than option. We have the less than or equal option, and we have the greater than or equal option for our linear inequalities. We're going to solve them the same way as we solve linear equations. However, our solution is not just one number. We have an infinitely many amount of numbers. For example, if it says x is greater or equal to 3, it starts at 3 and it goes to infinity. Let's take a look at an example for 2x minus 3 is greater than 5. This would be a linear inequality. We'll solve it the same way as we solve an equation. We're going to bring the 3 over. 2x is greater than 8, and then divide by 2. X is greater than 4. Now our answer has to come in form of a graph on the number line. So we have 0 here, 1, 2, 3, 4, 5. For example, x is greater than 4. If we show this solution graphically, we need what is called a parenthesis on the 4, and our inequality points to the right. That means our arrow has to point to the right as well. So wherever this inequality points to, that's what we need on our graph. Now let me remind you, or let me review real quick. You need a parenthesis if the number is not included. Parentheses for when the number is not included. In other words, this means if we have greater than or less than symbol, strict inequality. If we're having an example that says greater than or equal or less than or equal to, we need brackets to express our solution. So brackets like so, and that means the number is included in the solution set. Number is included, number is not included in the solution set. So we use this when we have greater than or equal to or less than or equal to. Now one other instance where we need parentheses if our solution goes to infinity on either side. Negative infinity, positive infinity always calls for parentheses. We're not done with our solution set here. This is the graphical solution. Now we can write it in interval notation. Interval notation, we're starting from the left and going to the right. So basically you copy your number line. We have a parentheses. At 4, 4 is not included, and how far do we go? We go all the way to infinity, and that is, of course, a parenthesis as well. So this solution goes from 4 not included to infinity. Let's take a look at one more inequality. We have to solve it just like a linear equation. We distribute the -2. We need to clear the parentheses. -2x, -2 times -7 is +14, so plus 14 is greater than or equal to 3x. 3 times 2 is 6, plus 6. The x values, the variable parts, I like to bring to the left-hand side, while I like to bring the numbers to the right-hand side. I always start with the variable first. I have a positive 3x. I'm going to subtract a negative 3x term from both sides. -2 minus 3 is -5x. Plus 14 is greater or equal to 6. The 14 needs to go to the other side by again doing the opposite, minus 14. -5x is greater or equal to -8. 6 minus 14 is negative 8. Now, to get x by itself, and here you go, pay attention. We're dividing by a negative number. Every time you divide an inequality by a negative numbers, what happens? You're reversing and you're going in the other direction. So that means negative 5 divided by negative 5 is 1x. X now, we reverse the inequality symbol. Do not forget that. Is less than or equal to negative divided by negative, let's keep it positive, 8/5. Leave it as a fraction. So again, if you're dividing or multiplying for that fact by a negative number, an inequality, you have to reverse the inequality symbol. Now, how do we show the solution now? On a number line, let's say 8/5 is right over here. The inequality points to the left. That means our arrow has to go to the left. But before, you have to ask yourself, do you need a parenthesis or a bracket? In this case, we're using a bracket because our inequality symbol is less than or equal to, bracket going to the left, like so. The interval notation for this particular problem would be, we're starting on the left, over here where my arrow is, and this arrow represents negative infinity. And where do we stop? We stop at 8/5. 8/5 in this case is included, bracket. Done, you are. This is your interval notation. We're looking at absolute value equations now. Here's an example. We have the absolute value of 5y minus 1 in absolute value bars, minus 7 equals 4. How do we solve these absolute value equations? Well, the first step is to isolate the absolute value bars. In other words, the expression that has the absolute value has to be isolated by itself on either side of the equations. So for us to make this happen, which would mean we have a minus 7 here, the 7's got to go. It's got to go to the other side. We're adding 7. That leaves me with the absolute value of 5y minus 1 equals 11. And now, just then, you can now solve this equation by rewriting it into two problems. You have to rewrite an absolute value equation into two problems, one that is equal to the number we have on the right-hand side, and the other equation which is equal to the negative number. Because absolute values, if you recall, a really quick review here, the absolute value of x equals 4, for example, which two values make this a true statement? Well, we can say x is equal to 4 because the absolute value of 4 is equal to 4, but we can also say that x is equal to negative 4. Why is that? Because the absolute value of negative 4 is also a positive 4. The absolute value is a distance problem. Distance from 0, distance is positive. So now I'm going to rewrite this problem without the absolute value bars. This becomes 5y minus 1 equals 11. That's my first problem. And the second problem would be 5y minus 1 equals negative 11. Now we solve this equation just like we would solve any other equation. Add 1 to both sides. 5y equals 12. Divide by 5, and yes, again, our answer is a fraction, which is 12 over 5. Beautiful. Now on the other side, we're solving plus 1, 5y, negative 11 plus 1 is a negative 10. Divide by 5, Negative 10 divided by 5, y is equal to negative 2. So we have two solutions. Again, if we check them, they both will make this absolute value equation a true statement. And when we have absolute value equations, we like to write the solution like that. Negative 2 with, I call them fancy braces, negative 2, comma, 12 over 5. Here you go. That is how you solve an absolute value equation. Now we're looking at absolute value inequalities. Absolute value inequalities, again, the difference between the inequality and the absolute value equation is the symbol. Absolute value equations have an equal sign. Inequalities have our inequality symbols. So here we get the absolute value of 3x plus 1 is greater than 5. Similar to equations, we have to rewrite this problem into two inequalities. The first one would be 3x plus 1 is greater than 5. And the second equation is 3x plus 1 is less than negative 5. Absolute values, we can have two answers, one positive, one negative. However, when we take it out of the absolute value bars, it will be positive, and hopefully we have the right answer. So let's take a look here. We're subtracting 1. 3x is greater than 5 minus 1 is 4. Divide by 3. And x is greater to 4/3. Now from previous work, you know that when we have absolute value inequalities that have the greater symbol in between, that turns into a compound inequalities with the word or in between. Let's solve the other inequality, minus 1. 3x is less than negative 6. Negative 5 minus 1 is negative 6. Divide by 3, which leaves me with x less than negative 6 divided by 3 is negative 2. So these are my two inequalities, and in between I have an or statement. I can again visually show this by using the number line. Let's say over here is negative 2, and here we have 4/3. So x is greater than 4/3. 4/3 is not included, which means I need a parentheses. My inequality points to the right, my error is going to the right. X is less than negative 2, less than, pointing to the left, parentheses, because we don't have an equal. In interval notation, two parts. Two-part interval notation. We start on the left-hand side, which is going to negative infinity, comma, negative 2, parentheses, union for or 4/3 to, where do we end up? At infinity. So when we have an absolute value inequality that has a greater symbol in between, what happens is it turns into an or problem. We solve the two inequalities, and then we write our solution according to our number line. Now here we have the absolute value of 2x minus 4. This time is less than 7. We rewrite the problem again. We have 2x minus 5 is less than 7, and 2x minus 5 is greater than negative 7. So we're changing the inequality and we're making the number negative. If we solve it, we add 5. 2x less than 12, 12, divide by 2, x is less than 6. Now with a less than inequality and an absolute value, our compound word we need in between in this case is and. And we solve this inequality. 2x is greater than negative 2, divide by 2. X is greater than negative 2 divided by 2 would be a negative 1. So x is less than 6 and greater than negative 1. Usually we say the negative 1 first. The order is not that important as long as you have the correct number line. Of course, negative 1 is on the left-hand side and 6 is right here. So our solution really means we are between negative 1 and 6, and they both call for parentheses. There you go, between negative 1 and 6. As an interval notation, we get parentheses negative 1 comma 6. Done you are. This completes how to solve absolute value inequalities. Another method of solving system of linear equations is called elimination method. Now, some books do also call this addition method. So addition or elimination method, they're both the same. Now that means, as the word indicates, in this case, we have to eliminate a variable. Now, either we're eliminating the x or the y. This really depends on the student. Which do you think is easier to eliminate? And when we eliminate, when I say eliminate, what that means is we have to have opposites. So in order to get rid of a variable, we either have to have a plus 3x and a minus 3x. So neither one of those two equations are set up that we can just eliminate. What that means for us is that we have to change the equations first. So I'm going to eliminate the y first. And let me tell you why I picked y and not x. And you got to look out for those things, because the y's already have opposite signs. That's how you eliminate a term with opposite signs. So if I pick the y, I don't have to worry about multiplying anything by a negative number. All I need to worry about now is what number do I need to multiply both of these equations by to get opposite number. And this is similar to finding the least common multiple, least common denominator. What is the least common denominator of 3 and 5? That would be 15. For the first equation, I already have a 3, so to get to a 15, I need to multiply every single term in the first equation by 5. So I usually put a little arrow there and write times 5, but sometimes I write it like this as well, so we don't forget the number on the right-hand side. Multiply everything by 5 is 30x minus 15y equals negative 15. Okay, there's my 15y. Now the second equation, I already have a 5y and I need to get to a 15y. So in this case, I need to multiply every single term by 3. Times 3, times 3, times 3. That gives me 4 times 3 is 12x plus 15y equals negative 27. Okay, we have opposite terms now. We can eliminate them. How do we eliminate? We add them. And that's why it's sometimes called addition method, because the next step is to add. 30x plus 12x is 42x. The 15y's, that was our whole reason why we did that, cancel out. And on the other side, we have negative 15 plus a negative 27, and that is a negative 42. Ooh, this works out fairly nice. divide by 42, both sides to get x by itself. Negative 42 divided by 42, the answer is x equals negative 1. This is our first value. Don't stop here. You also need to find the y value, and to find the y value, you want to substitute it into one of the two original purple, in this case, equations. So again, try to be smart about it. Look for signs. Do I have negative, positive, smaller numbers? In this case, it doesn't really matter. I'm going to substitute the x equals negative 1 into the second equation. And that way, I'm going to find y. 4 times x, x is negative 1, plus 5y equals negative 9. 4 times negative 1 is negative 4 plus 5y equals negative 9. Add 4 to both sides. 5y is equal negative 9 plus 4 is a negative 5. Oh, look at that. Divide by 5. Ooh, have no more room. Y is also equal to a negative 1. Negative 5 divided by 5. Therefore, our ordered pair is negative 1 comma negative 1. We get one solution, which is our first case here, where the lines, if we were to graph them, intersect. Here's another system of linear equations we want to solve by elimination method. Elimination method, you have to eliminate one of the variables. Let's take a look here. We have a negative x and a 3x. So I'm deciding, they have opposite signs. I'm deciding to eliminate the x. Now, I already have a positive 3x in the bottom, which means the top equation has to be multiplied by 3. Each single term multiplied by 3. I don't have to worry about a negative sign because I already have that here. 3 times negative x, negative 3x, plus 3 times 3 is 9y equals 18, 6 times 3. The second equation, I'm just going to bring over. I do not need to make any changes. 3x minus 9y equals 9. Now comes the eliminating adding part. So what happens here? Negative 3x and a positive 3x cancel each other out. Oh, look at that. 9 and negative 9y, they cancel each other out. The left-hand side, I'm left with 0. And on the right-hand side, I get 18 plus 9. 18 plus 9 is 27. So my variables all canceled out. I have 0 equals 27. Is that really true? No, that's not true. That's a contradiction. When this is the case, when you have your variables canceled out and that is equal to some kind of number, we get our parallel case. Here the lines, if we were to graph it, are parallel and we have no solution. This is our second case with no solution. Let's solve this system of linear equations by elimination method. Yes, we do have fractions, which I call fraction action. We need to clear the denominator here. That makes it way easier for us. So in other words, we're looking at the first equation and we have to find the least common denominator, and the least common denominator of 4 and 2 is indeed 4. We're going to multiply each term by 4. I'm going to write 4 over 1 so you know how to reduce this the proper way. Why do we do this? To clear the denominator. 4 goes into 4 one times, which leaves me with, let me write it down here, 3x. Now I'm going to the 5 halves times 4 over 1. 2 goes into 2 once and into 4 twice. I've cleared the denominator. 5, don't forget this 5 here. 5 times 2 is 10y. Now that is equal to, there's nothing I can reduce, so I just multiply 11 times 4, which is 44. Now I'm looking at the second equation, and I do the same thing with finding the least common denominator of 16 and 4, and in this case that would be 16. So I multiply by 16 over 1, 16 over 1, and by 16. Again, to clear the denominator, 16 goes into 16 once. 1 times x is x, minus 4 goes into 4 once and into 16 4 times. Don't forget this 3. Minus 3 times 4 is 12y. And here there's nothing to reduce, so we're just multiplying negative 16. This is our new system of equations. If we solve this by addition method, we want to now see, okay, which variable is it that I can eliminate? Which one is easier to eliminate? And if you look at the y term, you see you have a 12 and a 10. They have nothing in common, so I would have to change both of these equations. But if you look at the x term, we have a 1x and a 3x, so that is perfect. We're taking the second equation. We want to eliminate the x, and we do so by multiplying each single term by, I already have a positive 3, so in this case I would need a negative 3. Negative 3. So negative 3 times x is negative 3x. Negative 12 times negative 3 is positive 36y. And negative 16 times negative 3 is a positive 48. So I changed the second equation and I multiplied everything by negative 3. The top equation, I just copy over. There's nothing I need to change. Plus 10y equals 44. So I'm going to add both of these equations. I can eliminate the x's. 10y plus 36y is 46y, and 44 plus 48 is 92. I divide this by 46. 92 divided by 46. You either use your calculator or you know that 92 divided by 46 is 2. Y is equal to 2. Now you need to find your x value. I'm going to plug in the the y value into my green. I need to find x, not y. I'm plugging in the y value into the green equation, replace y with 2, and that way I can find x. X minus 12 times 2 equals negative 16. I have no more room, but I can. X minus 24 equals negative 16. Now to get x by itself, I'm going to add 24 plus 24. X equals negative 16 plus 24 is a positive 8. Beautiful. Here you go. Our ordered pair, in this case, they do intersect at one point, is 8, 2. This was our fraction system of equations. Let's take a look at systems of linear equations. What does that mean? Well, that means that we have more than two equations, or actually two or more. Can I start again? Two or more. I didn't want to say. Yeah. Okay, I'm ready. Let's take a look at. Okay, I'm ready. Let's take a look at systems of linear equations. System of linear equations have two or more equations. It really all depends on the amount of variables that you are looking for. We are looking for a system of equations that have two variables. So I have an example right here. They can be solved either by graphing, by substitution, or by addition method. Today I want to show you how to solve by substitution method. Now when we're solving those systems of linear equations, usually our solution comes in form of an ordered pair x comma y. So that happens real quick is if you have two lines, when they intersect with each other, that would be your solution. And this is in form of an ordered pair x comma y. Now this solution has to make both of these equations a true statement. If it doesn't work for one, then it is not a solution. Now something else can happen when you solve these linear systems. What can happen, it's better to show you graphically, if you have two lines and they do not intersect at all. They are parallel. If this is the case, if you have parallel lines, they do not intersect, so that would mean you have no solution here. A third case you could come across with, if you have two equations that look different, but however, when you graph them, you will see they are exactly identical. They just look different. Those are equivalent equations, but the graph is the same. When that happens, the lines coincide. It's called coinciding, and you have infinitely many solutions. Of course, the most common one is actually where the lines intersect and you get some kind of ordered pair. But be careful, sometimes you have no solution and sometimes you have infinitely many solutions. So let's go back to this problem. We want to solve this by substitution method. When you solve by substitution method, one of the variables always has to be isolated. So it either should say y equals or it will say x equals. In this case, this setup is beautiful. We already have y equals. Now we can just make this name proud and we can go ahead and we can substitute. We are substituting, we're replacing the y with x plus 2. Because, why do we do this? We can only solve an equation with one variable. So we try to change our equation into one variable. 3x stays the same, minus 2 times y. However, y is being substituted with what? X plus 2. And now finish up equals negative 5. So this is our new equation, and you can clearly see it has only one variable. Now we solve this equation by our conventional solving equation rules. 3x, we need to clear the parentheses and distribute the 2, but don't forget this is a minus 2, so we can just look at it as negative 2 times x, which is minus 2x, and negative 2 times positive 2 is negative 4, equals negative 5. We cleared the parentheses, combine like terms. Which ones are like? 3x minus 2x, beautiful. 3 minus 2 is 1x, minus 4 equals negative 5. the only step left is to add 4 to both sides, which leaves us with x equals negative 5 plus 4 is a negative 1. Now do not stop here. Since we have a value for x, we also now need to find the corresponding value for y. And how do we do this? We go ahead and we substitute, and we're substitute into the equation that says y equals, we're replacing the x with negative 1 plus 2. Beautiful. Negative 1 plus 2 is indeed 1. So we have found the point where the lines intersect, and we want to write this as an ordered pair. The last step is write it as an ordered pair. X comes first, negative 1, comma 1. Done you are. Let's solve this system of linear equation by substitution method. For substitution method, one of the variables has to be isolated. That needs to be our first step. So one of the variables needs to look like x equals or y equals. You have to decide which one you think is the easier one to rearrange. Here we don't have the setup. So one of these equations has to be rearranged. And if it is me who's doing the problem, I would go with the first equation. And you want to look for the variables being by itself. In other words, the coefficient is 1. So the only place where I see a coefficient of 1 is right here, minus y, this term. So I want to solve for y, the first equation. That means the first step is to subtract a 2x from both sides. Let me continue down here. Be careful. This one says negative y. Negative y equals, let me write the x term first, negative 2x minus 1. Am I interested in negative y? No. You have to change this to positive y by dividing by negative 1. All three terms. This becomes y equals, negative divided by negative is a positive 2x plus 1. So now I have accomplished my goal of isolating one of these two variables for either, in this case, y. What do I do with it? I'm going to substitute the y in the second equation with 2x plus 1. Why do I do this? To get an equation with just one variable. So now I'm copying the second equation, 5x plus 4, but the y is being replaced with 2x plus 1, and that is equal to 17. So this is now the equation I have to solve by clearing the parentheses first. 5x plus 4 times 2 is 8x. 4 times 1 is 4 equals 17. 5x plus 8x combined like terms is 13x plus 4 equals 17. Subtract 4 because we want to solve for x, and look how beautiful this is here. 17 minus 4 is 13. Divide by 13. X equals 1. Beautiful. Now we just have to find y. How do we do that? We're going to substitute again the x equals 1, and you substitute it into the equation that you have solved for y. That makes it easier. Y equals 2 times x. X is 1 plus 1. 2 plus 1 is indeed 3. Y is equal to 3. Our ordered pair, in this case, again, this is a case where the lines do intersect, and the ordered pair would be 1, 3. just like so. Here we have another systems of linear equations, so let's solve this one by substitution as well. As you can see, we do not have to isolate here because our first equation already says y equals, so the setup is perfect. All we need to do here is substitute. We're replacing the y in the second equation with 2x minus 5. So let's do this. 8x minus 4 times y. Y is, in this case, 2x minus 5. We're substituting the y, and then we continue on with the second equation, and this is equal to 20. Solve this equation. Distribute and clear the parentheses. 8x minus 4 times 2 is minus 8x, and we have a minus 4 times a negative 5, which is a negative 20, and that is equal, oops, that is not a negative 20, that is a positive 20. Negative 4 times negative 5 again, negative 4 times negative 5, positive 20, and that is equal to 20. So let's see what we can do. We combine like terms. 8x minus 8x, no worries. Yes, indeed, they do cancel out. That does happen sometimes. And what we are left with here in this particular problem is 20 equals 20. Now here on the other side, on the right-hand side here, are our three cases. We don't have a variable, so we're not solving for x and y in this case. They do not intersect at just one point. What happens is when the left-hand side is equal to the right-hand side, basically an identity, which means this would be our third case here, and we have infinitely many solutions. So if your variables all cancel out, and no worries, this does happen, then you have infinitely many solutions if you have an identity, what you're left with, if the left-hand side is equal to the right-hand side. That's the case here, which means the lines, if we were to graph that, would be exactly identical. They do coincide. They may not look the same, but if you solve this second one for y, you will see they're reducing, and it actually will be exactly the same as the top one. Infinitely many solutions.